All right, so today is our sister lesson to yesterday. Today we are subtracting rational numbers. So yesterday we added rational numbers, and today we are subtracting rational numbers. All right, so the same rules apply today than they did yesterday. All right, so I told you guys there's going to be some similarities. The same rules apply. Same sign, add and keep. Okay, we'll sing the song in a minute. Different signs, subtract and take. Remember, this is for addition and subtraction only. So we see that fraction rules apply. You must have a common denominator before you can add or subtract a fraction. Your decimal rules apply. You must line up your decimals before you can add or subtract a decimal. Okay? So remember, this is only addition and subtraction. The multiplication rules will be different. Okay? All right. So, in example 1, we see a lot going on here. Now, we're going to pull directly from our lesson yesterday. All right? So, we'll see who remembers what this double negative means when we get to it in just a minute. But before you can solve these, it's the same questions you ask yourself. When you look at number 1, I want you to ask yourself, is this same sign or different? Do you guys remember on Friday how I said, okay, is 1 positive or negative? And you would say 1 is positive. Now, is 4 positive or negative? It is negative. Why? Because it has the minus sign or the subtraction sign in front of it. So we understand that if I'm subtracting 4, that means 4 is negative. All right, is that starting to kind of sink in a little bit better? Just kind of nod or shake your head no. Okay, is that making more sense to you guys? So when I look at this, I think different signs. So what's my rule? Different sign, subtract. So what's 4 minus 1? 3. And take the sign of the larger absolute value. 4 is the larger number. It's larger than 1, and 4 is negative, so my answer is negative. Okay? Does everybody see why my answer is negative 3? Okay? I thought I had the song slide in here, so we do need to kind of back up just a little bit and sing our song together. All right? Sing it with me, guys. Same sign, add and keep. Different sign, subtract. Take the sign of the larger number, then you'll be exact. All right, let's sing it one more time. Same sign, add and keep. Different sign, subtract. Take the sign of the larger number, then you'll be exact. We got to sing it one more time because we don't have 100%. Come on, guys. Same sign, add and keep. Different sign, subtract. Take the sign of the larger number, then you'll be exact. All right, can we move on now? Okay, number 2. Is it same sign or different? Same sign. Is 5 positive or negative? Negative. Is 2 positive or negative? Negative. Because it has a subtraction sign in front of it, that means you're taking 2 away. 2 is negative. So, same sign, add 5 plus 2, and keep your negative. Negative 7. All right, let's look at number 3. Number 3, what do you notice on number 3? We learned it yesterday. We called it a double negative. And we want to get rid of our double signs, especially when it's a double negative. You guys remember what we talked about yesterday? They kind of collide, and then one of them turns vertical and turns the double negative into a positive. You can kind of turn it into a giant plus sign, okay? But you must change your double negative because now look, it changed your sign. Now is 6 positive or negative? Positive. Is 5 positive or negative? Positive. So 6 plus 5 is 11. And you did same sign, add and keep. They were both positive. All right. Now look at number 4. Number 4 looks a little different. Why? The double negative is in front. There's nothing in front of it. So that's still a double negative because there's no number in between. So yes, I still change the double negative to a positive. Anytime those two negatives are right together like that, they will cancel out to a positive. Okay? So now is 7 positive or negative? Positive. Is 3 positive or negative? Negative. So do I have same sign or different? Different. So what do? Subtract and take. 7 minus 3 is 4. 7 minus 3 is 4. 7's bigger. It's positive. But I know that 7 minus 3 is 4 anyway. All right. Now I want you to do numbers 5 through 8 on your own. When you finish, I want you to compare your answer with your neighbor. Okay. What'd you guys get for 3 minus 12? Negative 9. All right. We almost had 100% on that one. Okay. Different signs, subtract and take. 12 was bigger and it was negative. All right. So negative 9. Did you box it on your notes? Okay. So on the next one, do you see the double negative? Okay. Did you change the double negative to a positive? Okay. Now, that only changes that sign. You do not change the sign of the first number. The first number does not have a double negative, so you leave it negative. Okay? All right, so now what's negative 8 plus 13? Positive 5. Very good. Okay? What about 5 minus negative 4? 5 plus 4 equals 9. All right, and 9 minus 17? Negative 8. Okay, how did you guys do? Okay, how did you guys do? Hold up with your hand, hold up how many numbers you missed. So this would be a 0, a 1, a 2. All right, just kind of give me all right, good. Now, if you missed one, do you see what you missed? All right, do you see what you did wrong? So just as important as it is to get them right, if you got it wrong, do you see what you did wrong? Does anybody have a question? Okay. All right. So, yes, moving on to fractions. Now, remember, this is not necessarily a test of can you do complicated fractions. Okay. This is a test of can you apply your positive and negative rules to fractions. So, what do you notice about the first problem? What do you notice? It's got parentheses separating the double negative. Do you see that the first problem has a double negative just like you saw in the last example? So your rule will still be the same. You have to change that double negative to a positive. The parentheses separate the double sign. Okay, so if there was no parentheses, it would just be like two negatives back to back. So my rule says if I have two signs, I use parentheses to separate them. Okay, great question. Am I ready to combine these fractions? How do you know? Same denominator. Okay, so again, when you look at, was that a difficult fraction to add together?
Oh yeah.
You better say no, people. Okay? No, that's not a difficult fraction. So what I was testing you on was, can you catch the double negative? Okay? All right. So, okay. So now I have negative 3 1/3 minus 2/3. All right. Now remember, yesterday we talked about mixed numbers. All right. And it can get very confusing when you're like, okay, same sign or different sign. Do I add? Do I subtract? So yesterday I told you to do something to all of your mixed numbers. Make them improper. Okay. Now I understand sometimes you could combine them accurately by leaving it. But with multiplication, you have to convert it to an improper fraction. So it's just easier to say, anytime I see a mixed number, I want to convert it to an improper fraction. All right, so I have negative 10 over 3. Does everybody see how I got 10 in my numerator? 3 times 3 is 9, plus 1 is 10. All right, now I bring down negative 2/3. Now remember, the negative is never connected to the denominator, ever. So you don't say, oh, well, 10's negative here, but 3's negative here, so then these are different signs. Okay, you wouldn't do that. The sign is always connected to the numerator. Okay? The only thing that the denominator shows you is how many pieces are in the whole. Okay? Shoot, I need to answer that. Oh, well. Okay, so is it same sign or different? Same sign. Add and keep. Negative 12 over 3. Be careful. While you can leave something improper, you must reduce. Can this fraction be reduced? By what factor? 4. Now, I'm sorry, 3. But it goes 4 times. So I get why you said 4 because I was thinking the same thing. It can be reduced. You do not have to show this step. You can do it mentally. Okay? But I just want to show you what I'm reducing by to get negative 4 over 1, or negative 4. Now, we'll talk more about our division rules, okay? But for now, just know if I divide a negative by a positive, it will be negative, okay? All right, to reduce it. All right, so now let's look at the next one. What can I put a whole number over? 4 over 1 minus 11 over 2. All right, I want you guys to take about 30 seconds to a minute and subtract this fraction. All right, so did you get 8 over 2? Did you guys get 8 over 2? Minus 11 over 2. Okay, so now here's where you have to be very careful. Do I have same sign or different in my numerators? Different signs. 8 is positive, 11 is negative. Different signs, what? Subtract and take. So what would be my numerator? Negative 3. Why is it negative 3?
Because you're taking the sign of the larger number.
Because you take the sign of the larger number. So 8 and 11. 11 is bigger. 11 was negative, so my answer has to be negative. And think about it, guys. If you do 8 minus 11, that's going to be negative, right? 8 minus 8 is 0. So 8 minus 11 is going to be negative. Okay? All right, how do we do on fractions? Do we do okay? All right, now decimals. If you remember yesterday with decimals, we deal a lot with absolute value, okay? So the first question you have to ask yourself, is this same sign or different? All right, so let's look at the first one. 2.4 minus 5.6. Is this same sign or different? Different. So different signs, what do? Subtract their absolute values. So you must put the larger absolute value on top to be able to subtract them. Okay? Now, we'll worry about the sign of our answer in a minute. Now, are these difficult decimals to subtract? No, not even close, right? So that's a real fast. But now, what do you think I'm testing you on? Can you get the sign right? Is your answer positive or negative? Okay, I heard a lot of negatives. Why is it negative? Go back to the original. 5.6 was larger, and it's negative. Negative 3.2. Negative 3.2. Okay? All right, let's jump over here to the 8.8s. Okay? I want to just see what you can do on this one. All right? Give you just a couple seconds to see if you can figure out the answer. All right. What happens to that double negative? All right. They collide and turn into a positive. Does anybody remember the fancy word for this? Tell me. The fancy word. Additive inverse. Did you catch that? Additive inverse? 0. Any number plus its opposite is 0. Now, if you didn't remember the fancy word, that's okay. All right. Okay, I want you to do the last, actually, because they're very, yeah, let's do both of them. All right, go ahead and try the last two. Try the last two. Compare your answers. Done? Okay, so different signs. 0.45 is positive, 0.5 is negative. Did you put 0.5 on top? 0.50. 50 is bigger than 45. So when you subtract them, 0.45, you get 0.05. Is your answer positive or negative? Which one's bigger, guys? 50. 0.5. 0.5 is bigger. Okay? Remember, look at your tens place. There's a 4 here and there's a 5 here. So the 5 is bigger, your answer is negative. All right, now here's the downside about these quizzes and tests for this unit. All right? Even if you do your subtraction perfectly, if you don't get the right sign in your answer on these in this unit, it's completely wrong. I can't do partial credit because that's what I'm testing you on. Can you get the sign right in your answer? Okay, now of course you do have to subtract right also. Okay, all right, 4.9 minus 1.6 is different signs, so this one was a little more straightforward. 3.3 is my answer. Why is it positive? 4.9 is bigger. Okay, my beautiful friend, the commutative property. Okay, all right, so use the commutative property. I want to group together terms that will make it easier to solve. Okay, terms that's going to make it easier to solve. Here's where you might say, well, Ms. Kinder, like if I just left that a mixed number, you know, you kind of added a step when you didn't have to. All right, I would agree on this problem. However, you're going to spend a lot more mental capacity trying to figure out when it can stay a mixed number and when it can't versus just changing them all to an improper fraction when you see it. Okay, so does that make sense? So instead of you guys stressing, oh, can I leave it? Can I not? Just do it. Just change it. Okay. -2. And I would put it over 1. Okay. Or you could just leave it -2. Minus 2/5 plus 8/5. Okay. -2. All right. Now, what is negative? Be careful. What is -2 plus 8? No. What is -2 plus 8? Positive 6 plus 6/5. Okay? So that's really important because you might say 10/5. Okay? All right. So then you need a common denominator. Okay, so what would I multiply the first fraction by? 5. Very good. Top and bottom. -10/5 plus 6/5 equals what? What does that equal?
Positive 4/5.
Why would it be positive?
-4/5.
Okay, don't guess. Don't guess. What do you think, Kaylee? What did you say? Yes, very good. Why would I say -4/5?
Because the negative 2 is bigger than 1.
10 is bigger. 10 is bigger. -10 minus 6, guys. -10 has the larger absolute value, so I keep the negative, or I take the negative. -4/5. All right, now, what do you see, or what do you think you would do first on the next problem? What would you do first? Nope. What do you have to do first? Get rid of that double negative. Okay? Now, you can rearrange these however you want. So before you just start rewriting stuff, which numbers do you think would be easy to match up together and actually solve maybe even mental math in your head? You can, but that's not the easiest one to me. Yes. What about 7.8 plus 1.2? Yes. Can you do that in your head and say 9? Okay. Now, what about 9 plus 4.3? And then we have minus the 3.3. Okay. So now I have 9 plus 4.3 minus 3.3. You really can do it either way. And I don't care. When I'm looking at this, I think, well, 4.3 minus 3.3, that's pretty easy. It's 1. 9 plus 1 is 10. All right? Now, commutative property, guys, you're going to end up doing a lot of that in your head. But I want you to start rearranging those numbers to make it easier to add and subtract. All right. We're going to shift gears a little bit and talk about distance. Okay, we might leave that modeling real life for tomorrow. Okay, the values on. Now, I need you to kind of separate, all right? I need you to understand that with distance on a number line, it's a different set of rules, okay? If the numbers are on the same side of 0, okay, the same side of 0, you will subtract their absolute values, okay? If the values are on opposite sides of 0, you will add their absolute values. So everything with distance is based on where is it in regards to 0, okay? If they're both on the same side of 0, I subtract them. If they're on opposite sides of 0, I add them. Add their absolute values. Distance is never negative. Did you ever, come home and you're like, whew, Mom, I ran negative 2 miles today in track and I am just so tired. Even if you ran backwards, it's not negative. Okay? All right, so let's do a couple and then we'll be done. Find the distance between -3 and 9. So let me ask you this. All right, let's draw a little number line. All right, 0 is right here. Where is -3 in regards to 0? On the left. So just put it over here on the left. Where is 9 in regards to 0? On the right. Okay, now you're not always going to have to draw the number line. But that should help you visualize, is this on the same side of 0 or on opposite sides of 0? Opposite sides. So let me ask you this. This is why we add them. How many units does it take you to get from -3 to 0? 3 units. How many to get from 0 to 9? 9. So that's why you add them. When they're on opposite sides of 0, you add their absolute values and you find the distance. Okay? All right. So now let's look at the next one. All right, here's 0 over here. -1/3. That's going to come first, right? Because that's not even 1. -1/3 is here and -2 is here. The only reason I'm drawing the number line is to show you, are they on the same side of 0 or opposite?
Like a visual?
Yes, it's a visual. Are they on the same side of 0 or opposite sides? They're on the same side of 0. That means I need to subtract their absolute values. Okay? I don't care that they're both negative. Distance is never going to be negative. Okay? So that's where the rules are different. All right, so I have 2 over 1 minus 1 over 3. All I'm doing is just subtracting the actual numbers. All right, can I subtract them?
No, you got to get that common denominator.
You got to get that common denominator. Okay, so what would I multiply the first fraction by? 3, top and bottom. Okay, 6 over 3 minus 1 over 3 equals what?
5
5/3. And you can leave your answer improper. That's the distance between the two of them. Okay? So distance is a lot of absolute value. That one's not that big of a deal. I thought we did mean in this one, but I think mean comes next week. Okay? All right, so that's everything you need to know for the lesson today.